Have you ever wondered how an inverter is made? The process might seem complex, but when broken down into simple steps, it becomes more approachable. An inverter, a crucial device that converts direct current, DC, into alternating current, AC, is made through a series of steps involving component gathering, designing, assembling, testing and closing, fine-tuning, implementing safety measures and documentation. Imagine a world where you're an electronics enthusiast. Your first task is to gather all the essential components. Transistors, resistors, capacitors, diodes, and a transformer top the list. But remember, the specific components you'll need depend on the desired power output and features of your inverter. Once you've gathered all your components, it's time to design the circuitry. This involves creating a schematic diagram detailing how each component will connect to the others. This step requires a keen eye and a deep understanding of electronics. Next, you'll assemble the components on a printed circuit board, or PCB. This is where your design comes to life. Proper soldering and connections are crucial here. A single mistake can lead to a non-functional inverter or worse, a short circuit. After assembly, it's time to test the inverter. Check for functionality and efficiency. You'll want to look at voltage regulation, waveform quality, and the inverter's load handling capacity. A well-performing inverter will have a steady output of AC even under heavy loads. Once you've ensured that your inverter is functioning correctly, enclose the circuitry in a suitable casing. This is not just for aesthetics, it's primarily for safety and protection. A sturdy casing can prevent accidental shocks and protect the delicate components inside from dust and moisture. Now, you're almost there. But before you start using your inverter, you'll want to fine-tune it for optimal performance. Adjust parameters as necessary to ensure that your inverter is running at its best. Safety is paramount in any electronic device, and inverters are no exception. Implement safety features such as overload protection, short-circuit protection, and overvoltage protection. These features can prevent damage to both the inverter and any devices connected to it. Finally, document everything. This includes the design, the assembly process, and the testing procedures. This documentation will be invaluable for future reference and troubleshooting. But remember, building an inverter requires advanced knowledge and skills in electronics. There are risks involved, including electrical hazards and potential damage to equipment. If you're not experienced in electronics, it's advisable to seek assistance from a professional or purchase a commercially available inverter. With that said, the process of creating an inverter is a fascinating journey into the world of electronics.